In this video we're doing another example number 2, of solving a problem using the method of joints. Okay, so as we get started, let's take a look at it. What joint do you think we should start with? Alright, so I'm looking at joint A. Joint A, if I do a free body diagram, that's a pin, so it's got an AX component and an AY component. Then there's also the force. I'm going to draw the force assuming compression. So here's the force due to AC, and here's another force due to AB. All right, so that's one choice. We could start at joint A. We could also start at joint B. We draw those forces in, 300 pounds coming down. Okay, and then drawing the member forces in compression, we have AB coming this way, and then in compression we would have BC coming this way. All right, so that's joint B. And then finally joint C. Joint C, I have a reaction force. It's a horizontal roller, so it's a normal force to the surface that the roller's on. And so I have this force coming up, I'll call that force C. All right, then assuming compression for the members, I would have BC here and AC here. Okay, so I'm trying to figure out where to get started. All right, a lot of times that's the question. How do you get started with a problem? I have these free body diagrams for each of the joints, and what draws my attention is joint B. Okay, joint B, I know this value, and there's only two other unknowns. Okay, so I could get started with joint B, and from there, that would give me enough information to solve the problem for the other forces that I'm looking for. So in this case, let's find all the member forces, okay, and then determine whether or not they're in compression or tension. Okay, so if I look at joint B, I can write sum of forces in the x direction, sum of forces in the y direction. Okay, I also know these angles theta. Okay, so theta 1 is the arctan of the rise over the run. Okay, so it has a rise of 20 divided by a run of 48. So there's theta 1. And theta 2, I can look at that angle over here. That has a rise of 20 for a run of 15. Okay, so there's my there's the angles that I'm going to need. Okay, so writing equations at joint B. I'm going to move this, make this smaller, move it up. Okay, writing equations at joint B. Sum of forces in the x direction, I have AB being positive. Okay, I have the projection of BC. Okay, so when I say projection, I mean resolve that into the horizontal component. So that would be BC times the cosine of theta 1. Right, both those are in the positive direction, so they get a positive sign, and that's equal to 0. Okay, so there's one equation. The second equation, okay, sum of forces in the vertical direction. AB doesn't have a vertical component, so this would be BC, and then resolving that in the vertical direction, that would be sine of theta 1. Okay, and then there's the force acting down, minus 300 equals 0. Okay, so from here we'd be able to solve for BC and AB. Okay, so I did that off to the side. I did it in MATLAB. You get AB is equal to minus 720 pound force. Okay, and that we assume compression, and you get BC equal to 780 pound force. Again, we assume compression. So what that means is that AB is equal to 720 pound force in tension. Okay, so here's our two answers for BC and AB. So the only thing we have left is to take a look at the answers or the force in member AC. Okay, so I look at a joint here and I know this force now because we calculated it. Okay, I know BC, we calculated that. So that would let me solve for AC, and if I wanted to, I could also get C. All right, so I take a look and I see that the AC component, I could write a sum of forces in the x direction, and I would get AC. All right, that angle for AC is theta 2. So AC cosine theta 2, and that's moving to the right, so that gets a plus sign. And then BC.
Here's what I found.
BC is moving back to the left, so that's a minus, and you resolve that in the horizontal direction, and you get cosine again, theta 1. All that's equal to 0. Okay, so that gives you the extra equation that you need. Let me move this a little bit over. Okay, because I already know BC, I can plug that in and solve for AC. And so when you do that, you can check the answer. You get that AC is equal to minus 1,200 pound force. Okay, so that would mean
2 minus 1,200 is negative 1,198.
Sorry, my Siri just fired off. Okay, so that would mean AC is, remember I assumed it was in compression, so AC would be 1,200 pound force in tension because of the minus sign. Okay, so those are the forces. This is the solution to this truss problem. You need to practice these because they will show up on exam 2.